Hi students, in today's wonderful world of math, we are going to be talking about composite functions. So composite functions, you will know that it is a composite function when you see something that looks like this. So you will have one function, one function's name is g and another function's name is f, and in between them there will be this weird thing, which kind of looks like a multiplication circle or multiplication symbol, but it's open. So when you see this open circle, and you may have seen this on standardized testing before, this is called a composite function. So these are kind of like Russian nesting dolls. So if you can see this big cube, see it's plastic, then I have a smaller cube that would go inside of it. So what I would do is take my variable, put it in this small one, figure out what that gives me, shake it around a little bit. Then that gives me a different answer. I'll take that answer, put it into this big function, shake it around, do the math, and then that gives me a final answer. Oh, lovely. So let's see what's going on here. So this is kind of like, I think of it as like Russian nesting dolls. So what we do is we take our function that comes after the open circle, and that's what we use first. So draw a couple sets of parentheses. In this innermost parentheses is our x. Whatever number it gave you here, that's what will go here. Then we're going to put it in our f function. So I'm going to take whatever number that is and put it in the function named f. Then I'm going to figure out what that answer was. So that this is like the ping pong ball going into that one. Then I figure out what answer that was, and then that's like the softball, and I put it into g. And after I figure that out, that'd be like my heart. So when we do this, we will take, so let's write that out in words. So the first function, which was g in this case, it was named g, this one, the first one, is on the outside. And your second function, so what's our other function's name? If g is the first one, then my second one is named f. That goes inside the first function. Okay, so we've got some steps. Step one is to evaluate or take whatever number it gives you and plug it in to the inside function. The one on the inside here is f. Now yours on your assignment may be different letters, and that's okay. Let's get a little closer. There we go. Step two is to use the result or the answer from that function, so whatever number that gives you, that first function, remember our first function here is f, and we will take that number and put it in place of x in the outside, in this case g function. So as I explained kind of before, so we're going to take whatever number this is, put it into this function in place of the x's, figure out what that answer is, take that answer and put it into g. So it's all kind of a little abstract. So let's actually do one, and then that might make a little bit more sense. Okay, so it will say, not left, Mrs. Black, crazy, let. Okay, so our f function is going to be x minus 5, and our g function is going to be x squared. So let f of x equal x minus 5 and g of x equal x squared. So then we want to figure out what we need to do. So I want us to find g of f of negative 3. So g of f of negative 3. That's how you read that. This little open circle is read as the word of. G of f of negative 3. So the first one goes on the outside. Then I make my set of parentheses for that one. Then the next one goes on the inside. And I make my set of parentheses for that one. And I put my number in here. So remember, when you have something that looks like this, f of negative 3, what this part means is I need to use the f function. So it says use this one, the f one, and put negative 3 in for all the x's. So see, this is saying this is my function f with x in it. Here it's saying use that function f, but put negative 3 in it. So the g part is just going to come down on the outside. And this inside part here, I'm going to do x minus 5. But I'm not going to write x. What am I going to replace it with? Hopefully you know I'm going to replace it with negative 3. So negative 3 minus 5. Then we simplify and do math. So negative 3 minus 5 is negative 8. But I still have this g on the outside. So now this is saying the function g, put negative 8 in it. Well, here's my function g with x in it. So over here, I'm going to replace the x with negative 8. So I have negative 8, and I'm going to square it. So negative 8 squared is positive 64. And that would be my final answer. So these are kind of like two problems in one. Like you have to do one problem, then use that answer into the other one to find your final answer. Okay, so on this one, we're going to say let f of x equal 3x minus 4. And I want us to find f of 6. Okay, so I have f on the outside, f on the inside, and then 6 that I'm going to put in there. I should probably make that 6 a different color. Okay, so I find inside first. I find my function f, which is right here. And this is f of 6. This is f of x. So f of 6 is different because it means put the 6 in place of all the x's. So my outside function stays put. And I'm going to do this inside function. 3 times something minus 4. What is that something? This is 6. So 3 times 6 is 18. 18 minus 4 is 14. So I got 14. And now I'm going to do f of 14. So I'm going to take my function f and put a 14 in there. So back up here. 3 times what? Minus 4. 14. 3 times 14 is 42. Minus 4. So I get 38. Okay, so these are all just kind of two problems in one. Put one inside the other one, and then keep working. Okay, so when it's a number, it's not too bad. But do you think we're going to let it just stay numbers? No. So let's move on and look at it when we have letters in here. So when you have numbers, it's pretty much just calculations and mental math. Now let's get a little bit more challenging. So we are going to let f of x, for these ones, be 3x minus 5. and we're going to let g of x equal x plus 4. My first example, I want to find f of g of x. So f, small open circle, g of x. Okay, so remember, when I'm doing these, the first function goes on the outside. So f will be on the outside, g will be nested inside that, and I'm going to work this function with an x. Okay, so this first part is actually pretty easy because it says it wants g of x. Well, that says g of x. So I'm going to take what that equals and just replace it. So I have my f function, and I'm going to put g of x in there, x plus 4. Okay, so that part was pretty easy. G of x equals x plus 4, so I just replaced this g of x with what it equaled. Now is when it gets a little bit more challenging. So now, instead of just having one number or one letter like I've had, I've got an x plus 4. So what I need to do is take this x plus 4 and put it in to the f function. So we're going to find our function named f, and we are going to replace the x with our x plus 4. And make sure you put it in parentheses. We're going to replace any x's with x plus 4. Because this says I want my function f with an x plus 4 in it. So here's my function f. It starts with a 3, but then it has an x, and I'm not just going to put an x in there, I'm going to put the x plus 4 because that's what it says to put in there. X plus 4 minus 5. Now do you see why we have to have it in parentheses? Because we have to be able to distribute or FOIL or whatever it says. So we distribute our 3 into there. So 3x plus 12 minus 5. And then we combine any like terms. The 12 and 5 are like terms. So 3x plus 7 will be your final answer. So when you start with an x, you won't generally end up with a single number. You'll generally end up with an expression that will have a couple terms or so. Okay, so let's try that again. This time, let's try it backwards from that. Okay, so let's see if g of f is the same thing. G of f of x. So give me a guess really quick. What do you think? Do you think it's going to be the same thing or not? So what I want you to do right now is pause this, and I want you to try to do this setup for this problem. So pause it and try to do this setup. Which function goes where for this problem? Okay, welcome back. I hope you actually did take the time to pause it and make sure that you could set this up, because you're going to have to do that on your assignment, and I want to make sure that you know how to do it. So our first function goes on the outside, our second function goes on the inside, and x in the very center. Okay, so our function on the outside just chills. We need to work, remember PEMDAS, we work inside out. So this says find f of x. Well, if I go up here, f of x is already there. It's 3x minus 5. So we're going to write that in. 3x minus 5. Okay, now this says g of 3x minus 5. G of 3x minus 5. So what we need to do is find the function g and replace the x with, in parentheses, 3x minus 5. So that's what we are going to do. So here's our function g. Right here, it says x plus 4. So I am going to have my 3x minus 5 in place of that x. So instead of writing x, I wrote 3x minus 5. And then I'm going to write plus 4. Okay, so double check inside the parentheses. Is there anything I can do? Nope. So this just becomes 3x minus 5 plus 4. Combine like terms. Let's see. My like terms are 3x minus 1. So that is my final answer. So were those the same? Our composite functions, can I do them backwards and get the same answer? Looks like no, I cannot. So they do matter what order you do it in. So you do have to make sure that you know how to set these up, because if you set it up in the wrong order, you'll get the wrong answer. Okay, so make sure your first function goes on the outside, second function goes on the inside, and whatever you're doing goes in the innermost. So you put that into this function, then that answer into the outside function. Okay, a couple more things and then we'll be done. So I have one last example for you. If I have f of x equals 6x minus 2, and I need to find f of a plus h minus f of a, all divided by h, when h does not equal 0. So this is one of those application things that we will have applications for. So we need to work this function. So this one, f of a plus h, what that part means is find function f and replace all the x's with a plus h. So let me draw a really long fraction bar. That's what we need to have. And I want my function f, which is good because that's the only one I have. And in this green color, I'm going to replace the x's with a plus h. So I have 6, but I'm not going to write x. I'm going to write a plus h minus 2. Then I have a subtraction sign. And in my next one, I want f with a in it. So I'm going to take my f function and replace the x with an a. And since I have two terms that are being subtracted, I need to put these in parentheses. If there's only one term, I wouldn't, but I have two terms, so I need to make sure to distribute this negative. And that's all going to be divided by h. So right now this looks kind of nasty, but let's simplify. So doing math looks like here I've got some distribution to do. So if I distribute that, I'll have 6a plus 6h minus 2. And here, remember, this is negative 1. I need to distribute that as well. So negative 1 times 6a is going to be negative 6a. Negative 1 times negative 2 is going to be positive 2. And that is all going to be divided by h. So now let's look in that numerator and see if there's any like terms I can cancel. Well, I have a 6a. Do I have any other things with a? Yep, here's one. A negative 6a. So if I have 6a minus 6a, those, being the same and opposites, will cancel. Now let's look and see if I have anything else. I have 6h. Do I have any other h's up there? Nope. Okay, so that 6h is going to come down. Next I have a negative 2. Do I have any more numbers without letters? Yep, there's one. So negative 2 and positive 2, oh, those cancel. So it looks like 6h is the only thing I've got going on there. 6h divided by h. Well, if you notice, since there's no addition or subtraction, just division, h divided by h is 1. So my final answer here is just 6. Okay. I also want to give you just a little fraction reminder here. And if I'm giving you a fraction reminder, what does that tell you is probably on your assignment. Hopefully you know that means there's going to be fractions. Okay, if I have 2 and I'm multiplying it by negative 1/3 and then I am subtracting 1. Okay, so 2 times negative 1/3 minus 1. 2 times negative 1/3 minus 1. So remember, by order of operations, we have to multiply first. And remember, to multiply fractions, we need them both to be fractions. So how can I make this 2 be a fraction? Well, if I put it over 1, then I can multiply that by negative 1 over 3. And eventually I'll get around to subtracting this 1 from it. So when I multiply that, I multiply the top times the top. When you're multiplying fractions, you multiply straight across. Do not cross multiply. You only cross multiply when there's an equal sign in between them, which is not the case here. So we multiply straight across. So 2 times negative 1 is negative 2. 1 times 3 is 3. And then I need to subtract 1 from that. Well, to do any addition and subtraction, remember they have to have the same denominator. So I can put this over 1. And then what do I need to multiply it by to make sure that I get this denominator of 3? Well, 1 times what gives me 3? 3. So multiply it by 3 over 3. So I have negative 2/3 minus 3/3. Negative 2 minus 3 is negative 5. And we keep the thirds. So that would be your answer if you were doing a problem like this. Okay? Good luck on your assignment, and let us know if you need assistance.